My amazing math students, this is Mrs. A and I love math. And today we're doing lesson 71 in your Saxon Orange book, and we're talking about trinomials with common factors. And this one's going to be a pretty short lesson because it is basically the one we just had plus pulling out a greatest common factor first. So here we look at this trinomial, but this is not a quadratic trinomial. This is a cubic trinomial because the greatest power is a 3. But if we look and say, oh, you know what? Each one of those has a common factor, x. So we pull out an x, and then we're left with this divided by an x is an x squared. This term divided by an x is 6x, and this term divided by an x is 5. So now we can further factor into x and x. We read our signs and see what they're telling us. That's a positive. That means these two are the same sign. Since that's positive, that means they're both positive. And this term is a sum of the inside and outside terms. So since this term is a sum, we write down all the factors of 5. 5 times 1, that's the only factor of 5 because 5 is prime. So 5 plus 1 is 6. Therefore, we're going to put a 5 and a 1. 5x plus 1x is 6x. And then we have the 5 on the end and the x squared on the front. And we are done with example 1. For example 2, we have to look a little bit harder. We have a 4b and an x that we can pull out of each one of these terms. So we're going to pull out a 4bx. This divided by 4bx leaves me just an x squared. This divided by a 4bx leaves me with a negative x. This one divided by a 4bx leaves me with a negative 20. And now I'm ready to factor the rest of it. So 4bx stays there. Then I'm going to do my unfoiling method, x. There's a minus sign, which means these two must be opposites. So we can put them in if we want to. We just have to be very careful which way we put these. 20 could be. Now, what are my different factors of 20? 20 times 1, 10 times 2, 4 times 5. Aren't those all of the factors of 20? There aren't any others. So now we're looking for factors of 20 that have a what? Difference of 1. So aren't we going to use the 5 and the 4? And the middle term is negative, telling me that the bigger of the two numbers is going to be negative. So it'll be negative 5 and positive 4. So now let's check. 4x minus 5x gives me the negative x. The product is negative 20. And we are good to go with example number 2. All right, so the first one we have up here, look, it has got a negative x squared. We never want to factor anything with a negative on the front. So what if we pull out a negative 1 and then we just change all the signs? X squared minus x minus 20, and that should look kind of familiar because we just did the same one. So negative 1 x 20 is 5 times 4, and that's a difference of 1, right? So minus 5 plus 4, the exact same factors as the one we had before, but we had to pull out the negative 1. So we would leave the negative 1 out here and write those factors like that. Look at the next one. We have a 3 and a negative. We don't want that negative on the front, so we're going to pull out a negative 3x. And each one of these is divisible by the negative 3x. So now let's figure out what we have left. This one divided by negative 3x will be x squared. This one divided by negative 3x is 2x. This one divided by negative 3x is a negative, and 72 divided by 3 is going to go 24 times, negative 24 times. So now we're going to finish this up. Make sure to copy down your negative 3x, factor, x, minus sign. Minus sign tells me these are opposite signs. That means this one is a difference of the two factors. So let's write these factors down. 24, 1, 2, 12, 3, 8, 4, 6. And I'm looking for a difference of 2. So I'm going to use the 6 and the 4 because their difference is 2. And I want the bigger one to be positive. So positive 6 minus 4. So that is the last one. And that one was the one up before it. And we are ready for the second section of this lesson, which is subscripted variables. Okay, so subscripted variables are just a way of representing something. In the past, we have solved systems of equations using x's and y's, and we have also represented unknown numbers with an n very often. And here they're just introducing to you the idea of a subscripted variable, where something like n sub n would equal the number of nickels, and n sub d would equal the number of dimes. Actually, very often when I'm doing a problem like this, instead of number of nickels, I will just let n be my number of nickels and d be my number of dimes. So you have absolute freedom with variables, whether you use n sub n or n sub d, or whether you use n and d for nickels and dimes, matters not at all. So in this example, they asked me to use elimination to solve this system of equations. So I am going to take this equation. Elimination, remember, it means I'm trying to get rid of one of these variables. What if I take this bottom equation and I multiply it by negative 5 all the way across? Then wouldn't these two variables disappear? So when I do that, I'm going to get negative 5, number of nickels, minus 5, number of dimes, equals 16. No, times 5. 16 times 5 is 80. I have to multiply everything by negative 5, so I have to correct that. All right, so now adding this one to this one, these are going to cancel. I'll have 5 times the number of dimes equals 125 minus 80, which is 45. Therefore, my number of dimes divided by 5 is 9. And if my number of dimes is 9, then I can take that back up here. Number of dimes is 9. That means my number of nickels plus 9 is 16. That means my number of nickels is 7. Then I would go back up here and I would check. 5 times 7 is 35. And 9 times 10 is 90. And if I added 35 and 90, would I get 125? And I would. So we could solve using that. Now, would it have made any difference if I had, instead of using number of nickels, just used n for nickels? Wouldn't have mattered. And very often I'll do that because I think that the variable just n instead of number of nickels is easier for me to not get lost in the subscripts. Okay, so very often that's what I would do. I would just call it n and d instead of n of n and n sub n and n sub d. Really doesn't matter. They're your variables. So you can make them what you want them to be. Unless you're told what to make the variables, then you have freedom to make the variables what you would like it to be. what you would like them to be. Okay, here we're asked to do this one with substitution, and it is set up for substitution. Here, instead of number of nickels, n sub n, I've just used n. And instead of n sub q, number of quarters, I've just used q. And here, I did the same thing. So I just simplified a little bit by using different variables, which is fine. So now I'm going to solve by substitution. I'm going to take this q and slide it up there. So we'll have 5n. This is my basic equation. This is my sub. I'm going to copy my basic equation till I get to my sub. And then I'm going to sub in n plus 2 equals 290. So now I get 5n plus 25n plus 50 is 290. So now we're going to add these together and get 30n. And then subtract the 50 from the 290 and get 240. Divide the 10 on both sides. 24 divided by 3 is 8. So the number of nickels is 8. And if the number of nickels is 8, then the number of quarters is 10. And then we go up here to check. The number of nickels was 8, so 5 times 8 is 40. And then 25 times the number of quarters. The number of quarters was 10, so that would be 250. And is 40 plus 250 equal to 290? And it is. So that would be a very simple way to work that problem. Now we're ready to go to our practices at the end. Okay, here's your first practice problem. We're going to pull out a greatest common factor of negative 4x. This one divided by negative 4x is going to give me an x squared. Second term divided by negative 4x will give me a positive 7x. Third term divided by negative 4x will give me a positive 12. So now keep your negative 4x. Write your little unfoil parentheses there. Plug in your x and your x. Positive, positive means same sign, both positive. 12. So this one is a sum. So we have 12 times 1, 2 times 6, 3 times 4. We're looking for a sum of 7 when we use the 3 times 4. So we put a 3, put a 4, and we are done. So when you multiply all this back together, you get this up here. Try it. Okay, so this is B. Copy it down and then pause your video. I hope that when you did that, you discovered that the 2x and the 24 are in the wrong place. We're going to pull out a negative 1, but we're also going to switch these two terms around. So we're going to pull out negative 1 and get x squared. Then we're going to come do this one and divide by a negative 1, which makes it a negative 2x. Then this one, negative 24. So all we did was pull out a negative 1 and reorder. So now keep your negative 1, or you can just keep a negative. You don't have to have the 1, but it's not incorrect to write it either. Okay, a negative on the front is fine, or a negative 1. So we're going to have our x and our x. We have a minus on the end term, which means that these are opposite signs. One is positive, one is negative. The difference, because that's negative, this is a difference. So the absolute value of the two factors should have a difference of 2. So 24 times 1, 2 times 12, 3 times 8, 6 times 4. And we're looking for a difference of 2. 6 and 4 have a difference of 2. So we're going to use 6 and 4, but we want a negative in the middle. So we want our larger term, 6, our larger factor to be negative. So now let's check it. 4x minus 6x gives us the negative 2. 4 times a negative 6 gives us the negative 24. And there is our answer. We have factored completely. Okay, so this is letter C. our third practice problem, and we can do several things to make this one a little bit easier. We could replace n sub n with n and n sub q with q, n sub q with q, and n sub n with n. Okay, we're going to be doing substitution. Can you see something we could do right off the bat to make that one a little bit easier? Does each one of those terms have a 6 that we could factor out of it? Can we divide both the left and the right by 6? We could, couldn't we? Let's just do it and see how much easier our equation looks. So let's come down here. Divide this by 6, and I'm just going to go with the n and the q instead of the n sub n. Okay, so divide by 6, and we're going to have n plus divide by 6 for q, divide by 6, 60. Whew, much easier to look at. And so now this one is q equals n plus 5. So now this one is my main equation. This is my sub. I'm going to rewrite this, but then I'm going to substitute in. N plus 4q, q is n plus 5, equals 60. So when I simplify this, I'm going to get n plus 4n plus 20 equals 60. Okay, so I'm going to write that. Okay, I copied that on my smaller board just so that I would have it. That's exactly what we had at the bottom of the other board. So now let's distribute. N plus 4n plus 20 equals 60. So I can add these two together. 5n plus 20 equals 60. Subtract 20, subtract 20. 5n equals 40. N, remember n is number of nickels, equals, divide by 5, we get 8. So if n is 8, let's go back over here. Number of nickels is 8. Doesn't that mean number of quarters is 8 plus 5 or 13? Well, let's see if that's going to work back in our original equation. Okay, so 6 times the number of nickels, 6 times 8 is 48, plus 24 times 13. 24 times 13, 12, 6, 12, 6, 7. And then 24, and that's going to be 3, 1, 2. So we'll add a 3, 1, 2. Does that equal a 360? And it does. So we solved the problem. The number of nickels was 8, and the number of quarters was 13. And it worked. This is the last practice problem on this problem. Now, let's see if we can't make it a little bit easier. Okay, we're supposed to use elimination on this one. But you know what? I don't really want big numbers if I don't have to have big numbers. What about instead of multiplying this one by 6 or negative 6, what if we divided this whole equation by 6? Does 6 go into each one of those terms? It does, doesn't it? So let's take this one and let's divide it by 6, okay? And then when we do that, we're going to get, we'll use n instead of that one, get n plus 12 divided by 6 is 2d, and 180 divided by 6 is 30. Oh, much easier looking. Okay, so now, instead of writing this one down just like it is, because I'm trying to eliminate, let's just multiply this one by a -1 all the way across, which is just going to change the sign. This is going to be an n, remember, but it's going to be a -n. This one's going to be a d, but it's going to be a -d. And then this one is going to become a -12. So, n and negative n cancel out. 2d minus d is d. 30 minus 12 is 18. So the number of dimes is 18. So if the number of dimes is 18, okay, then, hold on, that doesn't look right at all. Did I mess something up? That one, 12, 30, and a negative 10. Let's see what I have done wrong. Okay, so I haven't done anything wrong, but the problem in the book does not mean nickels and dimes. It's just random variables because we're going to have a negative number of nickels to make this work. So just forget this is nickels and dimes. The example does not work in the book, but it's a perfectly good problem if you realize that something's going to be negative. Okay, so if we put 18 right here, then right here we're going to have something plus 18 is 12, so this one's going to have to be negative 6. Now, if we don't think of those as nickels and something that has to be positive, we're okay with that. So now let's just pretend it's a random number. Let's go back up here. 6 times negative 6 is negative 36, right? And then 12 times 18, 12 times 18 is 16, 8, 9, and a 12. So that's 6, 216. 216 minus 36 is 180, isn't it? So the problem works fine. It's just not nickels and dimes. Okay, it doesn't make sense in the context of nickels and dimes. The system of equations works fine. D is 18 and n is negative 6. So it doesn't work well with dimes and nickels, but it's okay if you just think of those as variables. Okay, so that was the end of that lesson. And this is Mrs. A, and may God bless your day.